Like I said, we'll discuss the code that we have so far. But before that, I'd like to show you the progress. So we have 2 enemies and 5 towers. I made these enemies. I disabled the script that moves them so we can test the towers. So we have the plant tower. This one just shoots one projectile straight forward. We have the wood cutter. This one gives coins. So these coins, you click on them and you receive coins. Also, they disappear after some time. They're not permanent. So if you wait without clicking, they should disappear at some point. Here you see it disappears without giving coins. We have the bomb. This one simple explodes on contact, gives deals damage in an area. We have the archer. This one shoots multiple projectiles at random enemies. I think it might be the share screen, that's why it's lagging a little bit. Okay, so I have this, and then this one just blocks damage. This guy stays there and blocks damage. We should resize this a bit at some point. So I have this. Now I'll start with the logic for placing towers. But first, let me explain the idea. So we have these objects with a box collider on them. I call them tower holders. These will hold the tower, and they have a box collider because we want to use the overlap point function to see if there's something below the mouse position. And these have a script that lets us know if this holder is empty or not. So at the beginning of the game, we spawn these holders by code to cover the area where the towers can be placed. Let's look at that logic. So we have a function that we use at the start of the game to spawn those holders. If you're familiar with two-dimensional arrays, it's a for loop within a for loop. So basically, in simple terms, we start from the top left corner of the terrain here, and we spawn those holders one by one from top to bottom, from left to right. So we have these two variables to let us know the length on the x-axis and on the y-axis of the terrain where we can place the towers. So in other words, here for each row, we spawn each column. We have this function that spawns those holders. Also, we make this be a child of an object here that will hold the holders. So that way we don't have a bunch of objects here in the hierarchy. Now let's look at how we buy towers and place them. First of all, we have a function that we place on the buttons. So when we click a button, we spawn that tower, and then we click to place it. So let's look at the function that spawns it. We use a parameter here, integers, to know which tower, because we have two arrays here. We have an array of towers and an array of prices. So know the prices for each tower. So we first check if we can spawn a tower. That means we can afford it, and also we do not have a tower selected already. In that case, we get the mouse position here in world space. And to do that, we use the camera. So we have this cam variable that we save the camera in this. And then we take this here, the input mouse position, that's the position of the mouse, but pixels on the screen. So we have to convert this from pixels on the screen to world space. So that's what we do here. And then on the Z, we place 0, because into the the z of the position of the object is 0. Um, then we spawn the tower that we selected and save it in a variable here. Also, we save the price of the tower because we only subtract the price when we place the tower, when we click to place it. That's when we subtract the price from our coins. So this is on all the buttons that spawn tower. Now for the placement of the tower, we have another function here, which we put in update. So every frame, because we check for click for input. So let's look at this. But excuse me 1 second. Okay, sorry about that. So let's look at the logic for placing towers. We can only place it if we have a tower in that variable. So if we are holding a tower, then every frame we get the mouse position in world space and we teleport that tower to the mouse position. So while we have a tower, we teleport it every frame to the mouse position basically. And then on click, so this means when we left click, we check if there is a collider below our mouse. We check for a holder below our mouse. So here we do that, and we select only the holders. So we have a physics layers for the holders. We only target holders with this. So if there is a holder, in that case, we want to see if that holder is empty, if it does not have a tower on it already. So we get the tower holder script here. We check if it is empty, and in that case, if it is empty, then it means we can place the tower. So now, because we placed the tower, the is empty bool here on the tower holder will be false because it's no longer empty. And then we do a bunch of stuff here. We make the tower a child of the holder. We place it in the center of the holder. We get the tower script here, and we enable it because we have a bool to control the towers. We save the holder in the tower script. We subtract the price from our coins. We update the text, the coins text, and now that variable that holds the tower is null. So there's nothing now in the variable, and this will stop this teleporting from happening. So we do this if the holder is empty. If it's not, we just destroy the tower because that means we cannot place that tower. Also, we destroy it if there is no holder below. So if the holder is not empty or there is no holder, then it means we cannot place the tower and we just destroy it. Wait, somebody messaged me somewhere. Okay, never mind. So that's the logic for placing the towers. Now this is for receiving the coins from the woodcutter, which we use in update, so every frame. So this is very simple. On click, we get the mouse position, and we check if there is a coin below, and then we receive the coins from that coin. So we spawn a visual effect, we get the coin script because that coin has a script which will which has the amount of coins that we receive. So we get the coins, we update that coin text, then we destroy that coin. Also in here, when the enemies reach the end of the path, we subtract 1 health here, and then when we reach 0, that means it's game over. Let me see. That's everything in the game manager. Let's start with the towers. The towers have 2 scripts. One is the tower script. This will have the properties that the towers have in common. And then we have for each tower the specific behavior. So for this we have health. We have this bool is active. So with this we can control the behavior because we don't want the towers to be active while we're holding them before placing them. At that point, we don't want those to be active, so we enable them when we place them. We have the tower holder. I don't remember why, but it's good to have this will be the holder um, below the tower. Here we have an array of sprite renderers. And the reason we have an array and not just one sprite is because the woodcutter, if you go to the woodcutter, we have to sprite objects with sprite renderers. And when we get hit, we want the white flash effect on both. So that's the reason we have an array instead of just one sprite. This is just for the coroutine. We have a coroutine here for the white flash when we get hit. And then we have the death effect. This will be an effect we spawn on that. By default, it's not active. We have the get hit function. We receive damage with this. So if the damage does not kill us, we enable the white flash visual effect. We subtract the damage from our health. If the damage does kill, then that means the tower, the holder below us is empty now. We spawn some visual effect and we destroy our tower. For the white flash, let's look at this here. I explained that again. To achieve that, we have a shader. If we go to the, let's say, the woodcutter here, if we go to the sprite renderer, you see there is a material property. So we use a material that has a shader to achieve this effect. I will send you the shader. I think I sent you actually already the shader on Discord. So once we have the shader here, we can right click create 2D. Wait, where's the material here? There's no material. One sec. Is that 2D actually? Excuse me, I am not sure if this is 2D because we have 2D materials and we have 3D materials. Yeah, I don't know about this stuff actually. Okay, one sec. I'm sorry. Materials. You also have physics materials. That's different. That's for physics. Let's see. There should be somewhere here in custom. Custom. Yeah, so that's how you do it actually. My bad. It's 2D. So you right click and create the materials, and once you have that, you can select from custom shaders this sprite flash shader. So once you have that, you can just drag and drop it here in the material. And now we have this here, this line. So we can get the material of the sprites and there, and then we can change a parameter in that in the shader of that material. In this case, is called flash amount. So this has this. If this is 1, then that means it's fully white. If it's 0, it's not white at all. And if it is between, then it's between not white and white. So let's look at the code. We have a duration for this because here we make it white over time. So this will be the duration of that effect. Also, the maximum amount of whiteness that we want. So here we make it white in here. I discussed this already. This is a for loop that counts time here. So we start from 0. And you notice this is a float, not an integer. So we start from 0. We go to 1. And in each frame we add the time difference between frames here. So that means we count time in seconds. So that means this will last 1 second if we just consider this part. But we want this to last a specific amount of time. So we divide by the duration here. So now this will last this amount of time. So in this case, 0.1 seconds. And because the woodcutter has multiple sprites, we have to apply the effect on all the sprite renderers. So for each sprite renderer in the array, we change that property over time from 0 to 1. That's what this does. So we use the mathflip function to do that. So what this does, it selects a value between a starting point and an ending point. So in our case, the starting point is 0, and then we go to the max white variable. So that's the whiteness that we want. Then the t here at the end uh, decides where between these two values we select the value. So if this is 0, we're at the beginning. If it's 1, we're at the end. And if it's between, let's say, 0.5, and then we're exactly in the middle between these two values. So that's what it does here. And then we do the same, but now from white to not white. Basically, we go from maximum whiteness to 0. So it's the same thing, but from the maximum white to 0. We have a function here because that starts this coroutine. And the reason is we don't want to start this coroutine while it is already running. So we check if it is running, we stop it, and then we start it again. And we save it in this coroutine variable. So we don't overlap this code. Okay, so that's the tower script. Let's look at each tower, each specific behavior. Start with the plant. Double click on that. 1 second. Yeah, we'll see. We'll look at everything. We'll look at everything because let's start with the plant. The towers have the tower tag and the tower layer. They have an animator for the animations, the tower script. This one has the plant script, and they have a collider for receiving that to receive damage. Let's go to the plant script. Okay. Now this plant also has a child here. This is just an empty object that represents the position where we spawn the projectile. And we spawn the projectile as an event in the animation. So we have the idle animation and we have the attack. And when we do the attack animation here, you see here at this specific frame, we have this event, which is basically a function that happens at this part of the animation. Also, we go from here in the animator. By default, it's in idle, and after we attack, we transition automatically back to idle after the attack animation is done. So here you see in exit time, it has 1. So that means it will wait the whole attack animation and then go to idle. Let's look at the code now. We have the tower script. We have the animator. We have an attack speed, attack counter in here we count time, and when we reach the attack speed, we attack. We have the projectile prefab and the position where we spawn the projectile, and then we have the enemy layer because we recast and we only want to target the enemies. At the start, by default, attack counter 0. We get the components here, and every frame, if the tower is not if it is not active, then we don't go. We say return, so that means we don't go further. We stop here. If it is active, we go further and we count time in the attack counter. And when we reach the attack speed, that means it's time to attack. We reset the counter. We recast to the right to see if there is an enemy. And in that case, here, so we check if our recast touched something. And in that case, we enable the attack animation. And like I said, we have the event on the attack animation that will spawn the projectile. So here is the function for the that we place as an event. It's very simple. We just spawn the projectile at the projectile position. I mean, at the spawn position with no rotation. That's what this is. Let's look at the projectile itself. The projectile prefab. This one has a script as well. That just moves it basically. So it has a rigid body, a damage and move speed, visual effect. This visual effect will happen on collision. For the start of the projectile, we get the rigid body and then we give it some speed. And that's it. That's what we do. And then on collision here, this is collision without physics. On trigger enter, we check if there is an enemy, if collides with an enemy. If there is an enemy, we spawn the visual effect for the collision. We get the enemy's kit and deal the damage to the enemy, and then we destroy the projectile. Also, if it touches the end collider, because there is a collider at the end of the path, we just destroy this projectile. That's the plant. Let's see. We have the. Let's look at the archer. This one also has a spawn point for the arrows. And like the plant, we spawn the projectiles as an event on the attack animation. This is very similar to the plant. Um, so here on the attack animation, we spawn those arrows here. The arrow itself, let's look at, actually, let's start with the archer script. So this is very similar. It's almost identical to the plant, if I'm not mistaken. So this part here is exactly this. It's exactly the same logic. If it's not active, we don't go further. We have an attack speed and attack counter. It's exactly the same. What differs is the spawn of the arrows. Is very different. So we have a coroutine here that spawns the arrows. This will be a bit complicated. Let me explain the logic first. I will actually play this. Let me explain the concept first. So these arrows follow an enemy with a certain speed, movement speed, and a certain rotation speed. Okay, but I don't want the arrows to go straight to the enemy. Okay, so you see they follow a random point in front of the archer, and then they follow the enemy. And to do that, what I do is I make an empty object. I spawn empty objects in front of the archer, randomly at a random position. And the arrows first follow that object, and after that they follow the enemy. When they first spawn and follow those random points, they have a low movement speed and a low rotation speed, and after they target the enemy, they go faster and with a faster rotation speed. So let's look at the spawn first. For the spawn, like I said, we have that empty object, and also those empty objects, they get destroyed after some time. Okay, let's see. So we have a coroutine because we don't spawn them all at once. We wait a little bit of time between each arrow. So we have an amount of arrows, we have a pause time. So that's the time we wait between each arrow. These represent how far from the archer are those, can those points be. So for each arrow, we spawn the arrow here and save the arrow script. Then here we create a random point in front of the archer. So create a random distance horizontally, vertically. Then we create that point. Let's see, and then we spawn that empty object at that random point here, and make it a target of the arrow at the same time. Then we give the arrow an initial movement speed and an initial rotate speed. And then we wait a very short amount of time between each arrow. Now the arrow script is a bit more complicated. Let's look at the archer arrow. This is the script on the arrow. So we have a damage, we have a target. This is a transform, not a vector tree. And the reason this is a transform and not a vector tree is because our enemies move, so it's not a fixed point. We have a movement speed, a rotation speed. Wait, somebody said something? Or what? Oh, okay. Sean left a message. Okay. So we have the rigid body to move the arrow. We have a destroy effect. So this on collision we spawn an effect, a visual effect. And then we have the enemy physics there here. So let's see. Let's start to get the rigid body. And then let's see, what is this actually? Yes, like I said, because at the start the arrows followed those random positions in front of the archer, we have a coroutine here that waits some time and then changes the target to a random enemy. That's what this coroutine is here. It waits some time, changes the move speed and rotation afterwards. And then here we select a random enemy and we follow that enemy here. So to get the enemies, we use the overlap circle function. So this creates a circle for one frame and checks if there are colliders within that circle. Once we have that, we check if the array of colliders is bigger than 0. So in other words, if there are enemies, and in that case, we select a random, we create a random index here, select a random, and select a random enemy. If there are no enemies, then that means we just destroy the arrow. We have the on trigger enter 2D on the arrow, so on collision with the enemy, we deal the damage to the enemy and we destroy the arrow. But I'm looking at this and where's the, I don't see the visual effect here. Also in fixed update here, so every frame, if there is no target, we try to find another target here. Because that what can happen is initially the arrow follows a target, but that target dies while the arrow is following it. So then we check, we want to switch targets in that situation. That's what we do here. We try to find an enemy and try to follow that. And if there is no enemy, that means there are no enemies. In that case, we just destroy the arrow. So if there is no target, we try to find one. As if there is a target, then we just follow it here. This is the logic for the movement. I don't fully understand, but basically this is the direction towards the enemy. Here we get the direction towards the enemy. I don't understand this. This is for the rotation. I don't fully understand it. This will rotate the arrow towards the enemy. This is very simple. This just moves the arrow forward. I mean the forward of the arrow. Which is, in our case, is not transform up, is transform right, because if we go to the arrow image, let me show you this. Let's see. Yes, this. You see, the sprite is oriented towards right, but that means we have to say transform right here. If it so this can be different depending on the orientation of the original sprite. So that's the archer. Let's see. Let's look at the woodcutter. This one's very simple. This guy here has just one animation. Jumps at the tree. The tree also has an animation that moved it slightly, simulating wind. I don't see the script. Oh, it also has a collider, but I'm looking at this and I realize it's misplaced. 1 second. Reposition. Okay, let's look at the script. So we have the tower script. We have the coin prefab, so the coin that we spawn. We have a spawn speed and a spawn counter. Start, we get the tower script. We make the counter 0. In update, if it's not active, we stop here. If it is active, we count the time. And if it's time to spawn, reset the counter and spawn our coin. The coin script is here. This is on the coin. This has a rigid body because it has a. If I simulate this, let me show you. When the coin spawns, it moves towards a random direction slowly, and it stops moving because we give it linear damping. So that's like a resistance to movement. It stops the movement slowly. Okay, so you see when the coin spawns, it moves towards a random direction and stops moving slowly uh, because of the linear damping. Okay, um, so we have the visual effect for the coin when the coin spawns. Also, the coin has a lifetime, so after some time we destroy it. Also, it has a minimum movement speed and a maximum movement speed. So with this, we can create a random speed between these two limits. In the sub function, we get the rigid body and we move the coin. So here we create a random direction first. So basically, we put a random number on the x and on the y from -10 to 10. But then we normalize it because we just want the direction, not the direction with the length 1. So this will take that vector, whatever it is, and make it of length 1. The reason is we want to multiply it with the speed. So after we create a random direction, we create a random speed from between the minimum speed and the maximum speed. And then we just make the velocity be the direction times move speed. The coin will stop moving slowly again because we have the linear damping on the coin. So if you go to the coin, to the rigid body, you see here linear damping is 3. So this stops movement. The more you increase this, the faster it will stop the movement. You also have angular damping for this will stop rotation. So if you increase it, the rotation will stop faster. We have the update function. Um, and I'm looking at this. This could have been. No, never mind. Okay, so we have the time lifetime, and we subtract the time difference between frames. So we subtract the time in seconds. When this reaches a value below 0, then that means it's time to destroy this coin. So we spawn the visual effect here, and we destroy the coin. So that's the woodcutter. Um, but let me show you also something. Let's look at the UI here. Let's look at the UI a little bit. So you have the canvas that's in overlay mode, so that means it's on top of everything. You want to scale here with screen size, so it stretches for different resolutions. I gave it reference resolutions full HD. We have this area here that will hold the buttons that spawn towers. It has a horizontal layout group, so with this you can place UI elements at equal distance from each other. And as children, we have the buttons that spawn the towers, which have the black background, an icon, and a text for the price. We also have an area here for the coins. So we have an image and a text. You notice that these arrows here in the corners, those are anchors. So by placing them in the corner, we make sure that these elements are all at that uh, position at with that size. That's the canvas. Let's look at the bomb. We'll skip looking at this here, the big eye. This is just doesn't even have a behavior. It just sits there and receives damage. This one. Let's look at the bomb. This one has just one animation. One second, let me my phone closed because I have the chat on the phone. So let's look at the bomb. We have a damage, we have the tower script, and we have the explosion. We spawn the explosion on contact. The damage, we deal the damage from here, but we also, when we deal the damage, spawn a visual effect. We have the range, so how we only target the enemies within this range. We have an enemy layer, the physics layer, because we'll use the overlap circle here function, and we only target enemies. So we get the tower script in the beginning. On trigger enter to this or collision without physics if the tower is active. So we only explode if the tower is active. So that means if we did not place the bomb and we're about to place it and it touches an enemy, it will not explode. It explodes only after it is placed. So if it is active, then we check if collided with an enemy. In that case, we spawn our visual effect, the bomb explosion, which is just an animation made with sprites. We make, because the bomb exploded, now the tower holder below it is empty now. So we make that holder empty. And now we use the overlap circle function to find all the enemies in the range, in range. And then for each enemy, we deal damage to the enemy, and then we destroy this object, the bomb. We destroy the bomb. So that's all towers. For the enemies, we have two enemies. We have this guy here that just moves and on contact with anything, deals damage and then disappears. And we have this guy here. This one walks, and if there is a tower within range, it stops and attacks that tower. So let's look at how this works. I noticed we have a bug with it. After it kills the tower, it does not stop at the next one. I don't know why. We'll see. I'll delete these two. And this one, let me re-enable the script. Let me show how this guy works. If I spawn this tower here, you see this guy stops and attacks it like that. So that's how that works. Let's look at the script for this guy. Because the other one is very simple. We just give it some velocity and that's it for the angry pick. Let's look at this guy. Let's see. We have the enemy script. Before we continue, actually, the enemies have two scripts like the towers. They have an enemy script with the properties they have in common, and then we have a separate script for the specific behavior. So for this guy here, we have a rigid body and an animator. Rigid body for the movement, animator for the animations. We have the raycast spawn. So this will be a position where we start the ray, when we raycast. We have a move speed, we have an attack range, attack cooldown, and we have the tower layer because we want to raycast only at towers. We have a coroutine here to save the attack coroutine, and we have the target tower here, and then we have some damage. In the start, we get the enemy script, we get the rigid body, we get the animator, and we give it some movement speed. And for 2D games, you can change the velocity on a specific axis. So I can say here linear velocity X. So we can change the velocity only on the X axis. So we say minus movement speed because we move to the left, not to the right. In update, we raycast each frame towards the left side within a range. We target only towers. So basically, we raycast to see if there is a tower in range. If there is a tower in range, that means it's time to switch to the attack coroutine. We have an attack coroutine here. So if it is not already in the attack coroutine, we save the tower that's in range, and we start the attack coroutine. If there's nothing in range and the coroutine is running, we stop the coroutine and we start moving again. It's very simple. And here we enable the run animation. It's very simple. If there is an enemy in range, we attack. If there is no enemy, we move. In simple terms, we have the coroutine for the attack behavior. Here we stop. First we stop the movement, and then here we loop forever. And we can do that because we stop the coroutine here in code. So we loop forever. But wait one sec. Yes. Um, so we attack, we enable the attack animation, we deal damage to the tower, and then we wait some time and we attack again. So we attack forever here. That's the behavior for this guy. I think that's all the scripts. We can continue a little bit if we have time. Pickle, you let me know if you have time, please. How much time do we have? 15 minutes? Okay. Let's do something simple because we don't have much time. Uh, there's one thing we can improve, which is for the placement of the towers. We can display the area where we can place those towers. So when we click a tower like this, let's see the possible squares where we can place those. Um, so what I think we can do is we can add a sprite renderer to our tower holder here. Okay, it does not have any image here. Let's add a square image. It is not the correct size because of the import settings of this here. So this white square has 500 pixels, but here in pixels per unit we have 100. So if we put 500 here, which is the real size of the square, and we apply this, now this should be the correct size. You see. Okay, let's give it some transparency, a little bit of transparency like that. And let's disable this by default. We disable it. Okay. So we want, when we place the tower, let's display all the holders that have that are empty. Now we have to go to the game manager uh, where we spawn the holders. We also want to save this. Um, we want to save this in a list, so we can enable the sprite renderer on those that are empty when we click a tower. Okay, so here we make a list, and this will be a list of let's say game object for now. Actually, no, we'll say tower holder. So we take the script, say tower holders. It doesn't work for some reason. Oh, I don't know why. Oh, we have to import this stuff. In the start function, here we make a variable of a list variable here, but there's nothing inside it. So you have to create an empty list at the beginning here. So new list tower holders. So this will make an empty list. Let's go to the logic where we spawn this. We want to save this in the list when we spawn them. So let's first say, let's just say game object new holder, let's say equal. So we spawn it first like this, and then we change the position. So we can delete this. We placed it at the correct position. So let's comment this. We spawn the holder, place holder at the correct position. Now we want to save the script in the list. Save script in list. So our holders add. Then we get the script for the holder. New holder, get component, tower holder, and that's it. Now we have a list. When we spawn the holders, we also have a list. Let's go. Well, we want to enable those when we click the button. So here at the end, let's say enable sprite on holders. So we can say for each tower holder, say holder in tower holder. We want to check if it is empty first. So if that holder is empty, if it is empty, we can enable the sprite. We can say holder that. But actually, let's have a sprite renderer variable in this tower holder script here. Okay, so this will be public sprite renderer. So now we can save the sprite renderer. So this script is on the holder. We also save the sprite renderer. So here we can say now holder that sprite renderer enabled equal to. So enable those. Okay, and then we want to disable these. So we can copy this code here. We want to disable these when we place the coin. So whatever happens in here, we don't care if it is placeable or not. We don't care about all this stuff. You only want to do it here on click. So when we click, whatever happens, we disable those colliders. So here we'll say disable sprite on folder. So you can say false here. And that's it, I think. Okay, so when we click the button, we enable those sprite renderers on the holders. And whatever happens when we click, regardless if you place the tower or not, we disable those sprite renderers on the holders. So let's see if it worked correctly. And I think that will be everything for today after this. So let's see. Yes, it does work. But you see we have this problem, which is the one that's below our tower was not disabled. Also, let's decrease the size a little bit. Uh, I'll make it slightly, the pixels per unit slightly bigger, so the area will be slightly smaller. Okay, so the issue is here, when we disable it only if these are empty. We don't care if these are empty or not, so I'll delete this. We just disable everything regardless of if it is empty or not. So now, because I changed the pixels per unit to a bigger value than the real image, the sprite will be smaller than the scale of the object. Now there's some space between holders. Okay, let's test that one more time. We click, yep, you see it does look better. We'll have to we can make an animation as well for the holders. I will do that the next time. So you see it does work correctly. But this guy doesn't, you see. It does not follow, it does not attack enemies after it kills one. I mean towers after it kills one. I don't know why. We'll have to see why that happens. That's everything for today. Thank you, Pickle, for joining me. If you have any questions, please ask now. And that will be everything for today. No questions? Okay, then thank you very much, Pickle, for joining me, and I'll see you next time. Thank you.